on the left, there's a quadratic inequality, right? Or a linear inequality, yeah? It's got a boundary line, splits the coordinate grid into two regions, one of which is where my solutions live, the solution region. The other one isn't, right? We're all this. We're comfortable with this, yeah? How would this graph look if it was a quadratic? What would the line be? So there's my line. Does that split the grid? Sure it does, right? Except the shape is different now, right? Now I've got this region out here, and I've got this region in here, right? One of them's the solution region, one of them isn't. It's the exact same thing, except instead of graphing a line, we're graphing a parabola. Now, what would happen if it was this inequality? Because what's that one? That one is this, right? Well, not quite, because it should have been, hold it. Let's do it properly. That's y is less than or equal to x, right? So how would it differ if I did x squared less than y? I haven't explained how the shading works, but what would be different? Yeah, it'd be a broken line because it's not equal to, right? So it would be this. Dotted. Otherwise, it's exactly the same. Everybody cool? If you can do this stuff with a line, which we just spent the last 2 days doing, you can do this stuff with a parabola. All right? So everybody's chill, yeah? Because we also just did a whole giant unit on parabolas, yeah? So we're going to put the two things together. Here's two quadratic inequalities, right? What would you do if this was last unit and I just gave you that? What's one of the things you would try? You'd try to factor it. I mean, it factors perfectly, right? What would it be? X, what? 3? Yeah. Would 3 and 1? How do 3 and 1 make 4? You got to multiply to 4 and add to 3. So what is it? Right? Would equal 0. Everybody agrees, yeah? Everyone can still factor, right? I hope. So what does that tell us? That gives us the roots, yeah? All right, so I've already graphed it for you to make it easy on us. There's our roots, yeah? Positive 4, negative 1, agreed? All right, now, so that right there gives me my roots. But if I want to graph it, I need more than my roots, don't I? If I was graphing this, what would I need to do once I had my roots? I need to find the vertex. And the vertex is, of course, root 1 plus root 2 divided by 2, which is 4, negative 1 is 4 plus negative 1 is 3. 3 divided by 2 is 1.5. That's my, right here, right? 1.5. And then I'd sub that back in and I'd get my y, right? And we'd graph it. Everybody remembers how to do this because we did it 3 days ago, yeah? Okay. Now, let's read this. Identify the x values. Remember, I only care about x values for which the inequality is greater than 0. Now let's have a look at this. Where is x 0? Oh, I just said where is x 0, didn't I? I didn't mean to say that. Where is the parabola 0? Where is the parabola 0? The roots, right? So right there and there, the red dots are where f of x is 0. That's the parabola, right? Now, where do you think the parabola is greater than 0? Where is greater than on a graph? Up. So where would that be? Anything above the roots, right? So, right there, yeah? Everyone agree? Where else? Right there, yeah? So where f of x is greater than 0, when does that happen? When x is what? No. When x is what? When x is 0, that's here. Okay, again, apparently I asked bad questions. All of you understand that this part right here is where the parabola is greater than 0, yes? All of you get that, right? Okay, what is the x value here, 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 here? What are all those x values? Great. No, of course they're greater than 0, but so are these ones. Thank you. X is greater than 4. Now, where else does it occur? When x is less than, not negative 2, what were our roots? When x is less than negative 1. Whew, which is out here. Now, please notice in this one, which I'll do in green, when is f of x less than 0? Well, if greater than 0 is above 0, then what must be below? What must be less? Below, which is where? All this, right? What are those values? Negative 1. How do I write this? This is grade 10 domain. How do I write that section of it? No. Yeah, no. Negative 1 is less than x because it's on the left, and x is less than 4. Now, because there's no equal sign here, is 4 and 1 allowed? No. Now, all of you, obviously I asked the questions weirdly. I didn't think I did, but hopefully all of you can see this. It's pretty self-explanatory, right? When the parabola is bigger than 0, it's greater than 0. When the parabola is less than 0, under 0, it's less than 0. Everybody cool? Now, before I go on, I need to make sure because, what if it was this? Where is it greater than 0? In the middle now, which is? Right here. If I do it that way, right? And when is it less than? Damn. There and there is the less thans. Does everybody see it? I'm sorry if my questions were confusing to people. Is everybody good? All right. So, turn the page over. Well, actually, no. We got some white space here. So let's remember. Still again, 1. Boundary line. Boundary line now is a parabola. Right? The parabola can be greater than 0, less than 0, greater than or equal to 0, less than or equal to 0. If it's greater than 0, I'm going to draw 2 of these. If it's greater than 0, where is the answer right now? There and there. Yes? If it is less than 0, where is that? There. Agreed? Oh, I did that badly. Less than 0, greater than 0. Let's draw another one. Where is that one greater than 0? Oh, wait. Let's do it this way so it's the other way around so we see everything. Where's that one greater than 0? Right there. Yes? And where is it less than 0? There. Everybody cool? Now, all of you should notice that all of those examples do something to the x-axis. What do they do? Not only do they split up the coordinate grid, what does it do to just the x-axis? It cuts it into how many? 3. If there's 2 roots, yes? How many times does it cut the x-axis if it's a 1-rooter? Let me ask you this. In this one, does x less than 0 exist? No. Does x greater than 0 exist? Where? The whole thing, except one part. Where? The very root. Good. Okay, so people are thinking. Good. All right, let's turn the page over, see what we can do. What do you want to do to graph? Remember, there's our inequality. So our first step is always a boundary line. And I even tell you what to do right here. I say graph the boundary line. How do you want to graph that? Your choice. What do you want to use? Better question, tell me what you could use. Because people are going to say different things. You could complete the square to get vertex form. Excellent. But most of you hate completing the square. So that one factors beautifully, doesn't it? Right? So if I factor that, I get x. What do I get? Negative 3 x plus 2. Yes? Right? So what are my roots? 1, 2, 3, and negative 2. Agreed? What's my vertex? Let me ask you this. Is the vertex particularly important that we get it exact? Is it? It's an inequality. I only need the regions, don't I? Don't I? So does the vertex really matter? Doesn't really. In this case, does it? Because we're practicing. But again, because we're practicing, let's find it just for the sake of finding it, right? What's the easiest way to find that? You could do negative b over 2a. That would work fine. Or we could do the roots. What's 3 plus negative 2? 1. What's 1 divided by 2? 1/2, right? Everyone agrees? And that makes sense. 1, 2.5, 1, 2.5, right? And then we run half through that. 1/4 minus 1/2, negative 1/4 minus 6, negative 6.25, yeah? So we 1, 2, 3, 4, 5, 6, and a bit. And now I can graph it. How would I graph that parabola? What kind of shape would I, or what kind of line would I use? Why would it be dotted? Because it's not equal to. So I know it's going to come down like this. Does it matter if it's exact, if I'm following my A perfectly? Do you think it matters? Doesn't. Why? Because I'm just looking to shade now, right? Now let's work through this. How many zeros does it have? 2 zeros. Which means, go straight to C, color the portion of the x-axis for which the inequality is true. Where on the x-axis is this parabola less than 0? The left, the middle, or the right? I'm going to turn this off, talk to your neighbors, because that was a simple question, and I'm reasonably sure everybody should be able to figure it out. The y values are all negative. The parabola results in y values, yes? So here is where everything is negative. So that part, I am looking for where the parabola is less than 0, which is right here, yes? Right? So where is the solution region of that? So we know it's got to be these x values, yes? So what y values are allowed? Anything in there. Everybody good? All right. So now write one or more inequalities to represent the values of x for which the function is negative. So lots of tricky math words in here, yes? I want inequalities to show the values of x. So I only need x inequalities, don't I? Right? So where is x values going to give me a negative parabola? What is the lowest x I can have where the parabola is negative? Again, we're just looking at the x-axis. The lowest x value I can have where the parabola is negative. -2. Can I hit -2? Why not? Because it's not equal to. It's a dotted line. So -2 is the lowest, but it doesn't equal -2. So what symbol goes here? Less than or less than and equal to? Less than. What goes here? X. What goes here? And what goes here? 3. Show these values on a number line. There's my number line. There's 0. Where would -2 be? Where would 3 be? Over here. Now what does that give us? Once again, I remind you, it shows there are 1, I've used blue already, 2, and 3 distinct parts to the x-axis once I have 2 roots, right? Everybody good? And all of those points are, here are all the points less than my root. These are all the points greater than my root. Everybody cool? All we've done is graph parabola and discussed what it means, yes? X are inputs, Y's are outputs. We know all that already. Let's look at number 3. Here is the graph. Here is the function, the quadratic inequality. It is greater than. So what am I looking for? The part of the parabola above or below the x-axis? Above for the greater than, right? Okay, so let's graph it. How do I graph the boundary line? How are you going to graph that one? That one factors to what? X minus 2 and x minus 2, correct? So what's the root? There's just one root. What is it? Positive 2. Agreed? Everyone agree? So there's my positive 2. Does it have an a value? So if I was going to really graph it perfectly, I could go over 1, up 1, over 2, up 4, right? So, which is the y-intercept. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So it's going to look like this, yeah? Everyone agree? Now this one's tricky. Yes, thank you. It does need to be dotted. Now this one's tricky. Color the x-axis where the inequality is true. Where is this greater than 0? Except where? Where is it not allowed? Just the root. Why? Because the root equals 0, yes? So, how do I write that as an inequality? What can x be? What are all of these values on the x-axis? This is just a grade 9 graph. What are all of these x values? X is less than 2. And what are all these values? X is greater than 2. How do I show that on a number line? There's 0. Where's 2? Right there. Is 2 allowed? So what do? A circle. Can't shade it. And then I go that way, and I go that way. Is everybody cool? How did I arrive at these inequalities? This inequality here, and this inequality here. What did I do? Yeah, but what were the important points? What showed me how to make those inequalities? The what? Right. I looked at the roots, and then I applied that to the shape of the parabola. What do I mean by that? Well, if I was looking for greater than, it was above the x-axis. Less than was below. And then I just did a grade 9 inequality graph. Inequality graph. Or the other thing you could look at that as is a grade 10 domain graph, right? Right? Because all of you should remember seeing this at some point. Right? Domain and range. We did a whole unit on functions. Well, there was that, all those notes, which there's 8 of them. Then I did one with dots. Then I gave you this worksheet.
Yeah, but I feel like we did that and we never did it again.
Well, I can't account for that. B, I'm here, aren't I? Yes, all right. So, what would you look for in the graph of the related function? Remember, that is the function, not the inequality. That is the unit for parabola. That's what I mean by the related function. When solving a quadratic formula, quadratic inequality in the form of this or this, what are you looking for? Okay, you got the greater than or less than signs. So there's my parabola. What are you looking for on that parabola? If you want greater than, what are you looking for? Where is the line greater than 0? What is the 0? The 0 of the parabola is the roots. But this is a result, yes? It's an output. So my outputs are what? Y or X? Y. So I'm looking for where the Y's are greater than 0, yes? So where are they? There and there, yeah? So what X values work? There and there. What if I'm looking for where it's less than 0? I need all this. So it's these X values. Does everybody understand? All right. What do you think, you try to write these, the 4 ways we can write a quadratic inequality with only one variable? Go. There's 4 ways you can do it. I'll give you a hint. It's exactly the same as the 4 ways you can write a linear inequality. What is one way I can write a quadratic inequality? X squared is greater than 0. Absolutely right. When we graph that, what would that look like? Dotted or solid line? Dotted. Happy or sad parabola? Happy. What's another way I could write it? X squared is less than 0. Happy or sad parabola? Still happy. Does it have any answers? No. Everybody understand? Why not? X squared can't go below 0. So can we change this to make it a little more general? What would I do to make this be a little more general? What would I have to do to this parabola to make it give me a better example? Right, I'd add a negative 4, so it drops straight down or something, right? So now it looks like that, yeah? And this one, negative 4, and I'd be cool. What's another way I could write this? X squared is greater than or equal to 0. And again, I'm going to add that negative 4, right? And what kind of line would it be? Solid. And then x squared minus 4 is less than 0 or equal to 0, which would be where? All right, now I'm going to use some colors. Where is that one? So, there and there, yes? Where is that one? Where is it less than 0? In the middle, because the x-axis is going to get split into 3, right? Where's that one? Actually, you know what? Let's do this just to be, crazy. So where is that? Where is it greater than 0? In the middle. And where is it less than 0? On the outsides. Is everybody good? If you can graph a parabola and you recognize that greater than is above 0 and less than is below 0, can you do this? Yeah, let's do. So there is my parabola, or my quadratic inequality. Step 1, just like in linear, is get the boundary line. The boundary line is f of x equals x squared minus 2x minus 3. Can I factor that? Can I factor it? Sure I can. What is it? X negative 3 x plus 1. Everybody good? So, what does that give me now? The roots. The roots are what? 3 and negative 1, yes? So let's put them on our graph. One, two, three, negative 1. Is it a happy or a sad parabola? Happy. Do I really care about the exact value of the vertex? Not really. But it's pretty easy to find on this one, yeah? Because what's 3 plus negative 1? Divided by 2? 1. So I know my vertex is at 1. 1 squared is 1. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4, right? So my vertex is at 1, 1, 2, 3, 4, negative 4. What kind of line do I draw? Why is it solid? Less than or equal to. Now, are we good? Are we good? Okay, so now we're going to use method 1 with a graph. When I do a graph, this is called inspection. And inspection is just a $5 word for I look at the graph. Where is the graph less than 0? I'm going to put 2 colors on here. 4 colors. No, just 3. There, and there. Where is the graph less than 0? The yellow, right? Everybody agrees? Okay. So, what is the... Can I equal 0? So what is the lowest x value that is 0 or less than 0? Negative 1. Less than or equal to what? X, which is less than or equal to 3. Does everybody understand? Right there. If you're going to graph it, that's the easiest thing to do. You just look. You inspect it. All right? But, do I need to graph it? Check this out. I have the roots, yes? Everyone agrees? Okay. What are the roots? 3 and 1. So, I know my values are going to be x values, yes? So, there's my x axis. What are the points that I know on it? Negative 1 and 3. Do we agree? Now, pretend we haven't graphed it now. We're just thinking about the roots, yes? Everyone agrees? Okay. And these roots are all x values, yes? You'll see in a sec. There's that section, and there's that section, yes? And all of those are x values, yes? Okay, everyone agrees? So it says use test points. What is a test point somewhere in that part of the solution? Negative 2. So there, x equals negative 2. Everybody agree? What is a test point in this section? 0. X equals 0. I'm going to use 3 different shades of blue. And what is a test point in this section? 4. X equals 4. How do I then take that knowledge along with that knowledge and find out what the answer is? Plug it in, because those are all x's, aren't they? So, the first one. Remember, the function I have, I am looking for less than 0, yes? So, this function, x squared minus 2x minus 3 must be less than 0, yes? What's going in for x? Negative 2 squared minus 2 times negative 2 minus 3 is less than 0. What's negative 2 squared? 4. What's negative 2 times negative 2? Plus 4 minus 3, less than 0. What's 4 plus 4? Minus 3. Is 5 less than 0? So are any of these points okay? They're garbage. Now we go to the 0 point. What is 0 squared minus 2 times 0 minus 3? Is negative 3 less than 0? So this part's okay, right? I don't even need to graph it. And then because we understand parabolas, we know that this isn't going to work, right? But we're going to do it anyway. 4 squared minus 2 times 4 minus 3 is less than 0. What's 4 squared? 16. Minus 2 times 4? 8 minus 3. 16 minus 8 minus 3. 5. Is 5 less than 0? No. So we can see that our answer is in the middle there, without even graphing it. Everybody cool? Now listen to me. I have to teach you the next method. I have to. I hate the next method. I have an answer.
So, couldn't we just take the roots and then use whatever sign it gives us in the original inequality to make the
What if it was an unhappy parabola?
That's what I was asking.
It won't work then, right? You have to understand what's going on. I don't like the next method, but I have to show it to you.
It's unhappy is just opposite of what it gives us.
Okay.
All the time.
I wouldn't. Okay. This is the yucky one. Case analysis. I love it. Use it all the time. It's terrific and easy to understand. Okay? Okay. We factored and we get to here, yes? For this to be true, less than 0 is negative, right? And I'm multiplying two things, yes? So, this factor would have to be negative, and this factor would have to be positive. That would get me a negative answer, wouldn't it? Does everyone agree? The other option is this factor is positive, and this factor is negative. Does everyone agree? There's two different cases that we could make for this, yes? In case 1, x plus 1 is less than 0, right? So if x plus 1 is less than or equal to 0, then x plus 1 would be negative, right? So let's solve that. X has to be less than or equal to negative 1. Do you agree? Yeah? Okay. Now, x plus 3 then, or x minus 3 would have to be positive, yes? Which would make x greater than or equal to what? 3. So now I have two number lines, don't I? Everyone agree? The pink number line would look like this. There's 0. Where's negative 1? On the left. There's negative 1, yes? Is negative 1 part of it? So close dot. And then what do I do? It's all those, yes? Everyone agree? Okay. Now on the gold line, there's 0. Where's 3? Right there. Is it included? Let's go out there. Now, what do you not see? Is all this part of the x-axis okay? In the pink line? Is it okay down here? No. Is all of this part of the axis okay on the gold line? But does it work up here? So with this case, is there any time where it's shared? So there are no values that work in both of them, is there? So it cannot be case 1, right? Case 1 is no, because there's no x values that work for both. So we go on to check case 2. In case 2, our pink one has changed now. It's the positive one, right? So how do I graph that? X plus 1 is greater than or equal to 0. So x is greater than or equal to what? -1. Yay! And then in gold, x minus 3 is less than or equal to 0. So x has to be less than or equal to 3. Yay! On the pink line, what's it look like now? -1. What kind of dot? Closed. And what parts count? All that, yes? On the gold line, what's it look like? 3. Is it colored? Do I shade this in? And what does it look like? All this, yes? What do you see right there? Shared. So that's where your answer lies, between 1 and 3. Does everybody see how it works? Please say yes, because I hate using it. I'm a test point man, right? You know that from the lines, right? Test points are so much easier, yeah? You just sub it back into the equation and see if it works. Everybody cool? All right, let's apply these. You solve this using 2 different methods. How many methods did I give you? 3. Graphing, and I'm not going to move my ring finger right now. That would be funny. Huh? One time I did that in one of my very first teaching year here. I was teaching grade 9. I was counting down from 3. I went 3, 2, 1. And right then, on 2 vice principals behind me. He couldn't see my hand, but all the kids are laughing. And I was like, what? I don't get it. Oh, hi, Mr. Pearson. Anyway, 3 methods. What are they?
Case analysis.
Draw the graph. Inspection, right? Check the roots as a test point. And 3 is case analysis. Try it. See what happens. Everybody good? Go. I'm going to split the page into 3. And of course, I'm going to do all 3. Graphing. Sorry, everyone, and I wasn't recording. But not like any, you're going to watch the video anyway. And it was spectacular. Yes. Yes. Do you have answers for me? Negative 3 and 4?
Yes. I said negative 4 and 4. I said negative 3 and 4.
How do you factor that? X minus 4, x plus 3 equals 0. So what are the roots? All right. Okay. No, Aiden didn't. I'm not trying to put anyone down. I just want everybody to be able to factor. So now we put them on a number line. Where does the number line live? Or what do I need on the number line? 4 and negative 3, yes? So now I have 3 sections, don't I? The yellow section, the green section, and the blue section, yes? I need to pick a test point from each section. What is a good test point from the yellow? Negative 4. What's a good test point from the green? 0. What's a good test point from the blue? 5. All right. So, negative 4 is x. What's negative 4 squared? But we can work here, can't we? Isn't this one easier to work with? So let's work with this. Negative 4 minus x, minus 4, right? Times negative 4 plus 3. What's negative 4 minus 4? Negative 8. And what's negative 4 plus 3? Negative 1. What's negative 8 times negative 1? Positive 8. And what's positive 8 with a negative in front of it? Negative 8. Is negative 8 less than 0? Sorry, less than, just less than. Is it? So is this part okay? Excellent. Now let's check with 0. What is 0 minus 4? And 0 plus 3. What's 0 minus 4? What's negative 4 times positive 3? Negative 12. But there's a negative out in front, so what does it become? Is 12 less than 0? Yes or no? No, so that's dead. Now, obviously, knowing how parabolas work, we know this is going to work, yes? But let's test it. What is 5 minus 4 is 1. 5 plus 3 is 8, right? What's 1 times 8? 8, but there's a negative out in front. Is negative 8 less than 0? So that's right, yes? So what does that mean? X can be what? Less than negative 3. Can it equal negative 3? No. Or x can be greater than 4. Does everybody understand? All right, now let's do the yucky one. What are my two choices? Either negative x minus 4 has to be less than 0, right? Or, and x plus 3 would then have to be greater than 0. That's one way that it would work, yes? What's the other option? Negative x minus 4 is greater than 0, and x plus 3 is less than 0. Everybody agree? Those are my two ways I would get a negative, yeah? Because this way, this is negative, this is positive, this is positive, this is negative, yeah? So what's this number line going to look like? How do I get rid of this negative number? This negative 1. I divide by negative 1, right? Everyone agrees? Divide by negative. What does dividing by a negative do to the sign? X minus 4 has to be greater than 0, so x has to be greater than 4, yeah? Right? Okay, what about this one? X has to be greater than negative 3, yeah? Everyone agree? Okay, now let's check this one. Same thing, divide by negative 1, flip the sign. X minus 4 has to be less than 0, so x has to be less than 4, yes? Everyone agree? And this one, x has to be less than negative 3, right? Right? Okay, how do I do this with case analysis? There's my line. This guy has to be greater than 4, right? That's where my stuff lives. And then this guy has to be greater than negative 3. Yes? This guy, x has to be less than 4. And this guy, x has to be less than negative 3. Everybody good? Where is the only place where it's always negative? Up here it's always negative, yes? But here it's no good, right? Because this part, no good. Here is always negative, yes? But here, no good. So where is it only negative all the time? Greater than 4 and less than 3. Everybody cool? I just make all the number lines and I check where it always works. Is everybody good? All right. Now, you can have graphing back. Practice this. You can use graphing, roots, or case analysis, or Jacob can use his crazy method that he is devising all by himself that has worked once and failed once. So he's got a 50-50 shot.
I was working on it. I was building it up.
That's cool, Jacob. That makes me really happy that you're building up your own thing. So everybody do that one. And then I think that's it. Oh, no, we got one more, but we'll come to that in a sec. Actually, I think we're going to run out of time. So today your work is just 142. Just do that one question. Then you got a 4-day weekend. I am giving you 4 days off. I, of course, will do all 3 methods, yeah? Actually, I got a lot of space to work. I'm going to go this way. The screen's on behind me, isn't it?
Yeah. Oh. I didn't even...
It wasn't supposed to be. Now everybody knows the answers and won't try it themselves. Damn!
Don't worry, my method worked again.
Your method worked again? You're up to 2 out of 3 times? If it matters, if it works in your head, that's all that matters. Everybody has, now you all saw the right answer. Bye, everybody. Yeah. Oh, man. When I did case analysis, I slid too far down the screen and I forgot the second root was -5. And I did all the work with +5.
Did it work out?
No. And now I'm recording myself saying I wrote it wrong. So now I got to fix it all. Great.